I'm going to prove that the area of triangles is always 1/2 base times height. So, in order to prove this, we need to understand the definition of area, which is defined as the number of 1x1 squares that fit inside a shape. So here I have an example of a shape, and we're going to use a rectangle. We know the area of a rectangle is base times height. So if I'm following the definition of area, number of 1x1 squares, my shape here is the rectangle, and I'm going to find the number of 1x1 squares that are inside. So by doing this, I'm going to have B columns and H rows. So looking at it, it's 1, 2, 3, 4, 4 down, and 1, 2, 3, 4 across. With a rectangle, this is going to be my base, and this is going to be my height. So again, the base is the B columns, and the height is the H, the number of rows. So the area of a rectangle is base times height, and if I'm following this, I'm going to do area equals 4, because my base is 4, 1, 2, 3, 4, and my height is also 4, 1, 2, 3, 4. So 4 times 4 is 16. So the area of this rectangle is 16. So now I'm going to prove that by using this definition of area, that all of the triangles, the area of them are 1/2 base times height. There are 3 types of triangles that we're going to look at, but the first one here looks like this, where the vertex is above the direct point. So most often of the time, these are going to be your right triangles. So the triangle that's shaded blue here is my original triangle with my base and my height. Because it has a right angle, I'm able to reflect it across the axis and double the triangle to create a rectangle. So here, after I've reflected it, I have my dotted line in green with the base and the height. And this makes a rectangle. And we know that the area of a rectangle is base times height because we just proved that. And so, since this is a reflection of itself over and it's a double, I have to divide it by 2, which then leads me to the equation of area equals 1/2 base times height. So that is the area of a triangle with the vertex above the direct point. My second triangle is going to be the vertex that is between 2 points, like this. So if I were to cut this triangle in half down the middle, I would have 2 small triangles like this with right angles, which we just looked at, so I know that I can add the reflection to create a rectangle. If I'm reflecting the triangles, these 2 small triangles are the reflections of it, and I can simply add it on top of the main triangle because I know that it's double of the mini triangles that I cut in half. So again, I create a rectangle after I cut in half to visualize that I can double them. In my new rectangle, we know that the area is base times height. When we divide it by 2, because of the half, I get area equals 1/2 base times height. So that is the area of a triangle with the vertex between 2 points. The third and final triangle is when you have a vertex that is outside of a point, like this, with no right angles yet. So if I look at this, I drop it down. This light blue triangle is my original triangle. I know the base because it's the bottom, however, I don't know the height. So to get the height, I'm going to take from this point, drop it down all the way, and connect it here. So I've just made a separate triangle in green here. So my height is now this unknown, and my base is still B, but I also have to count for X when I'm finding the area. So to find the area of this triangle, I need to understand that the area is equal to the area of the big triangle minus the area of the small triangle. And to get this, I know that the area of the big triangle will be 1/2 height, and the base of this whole entire triangle is X plus B. So I have that, and I have to subtract that from 1/2 X and H to get the small triangle, so I can eliminate this triangle and find the area overall. When I do that, I write out area equals 1/2 hx plus 1/2 hb minus 1/2 xb. That happens when I distribute my first line of the equation. After that, 1/2 hx minus 1/2 xb, I can cancel those out, and I'm left with A equals 1/2 hb, which can also be written as area equals 1/2 base times height. So, yes, indeed, the area of all triangles is equal to 1/2 base times height.